that up to now in uncertainties is when we've got, say, one value and we take several repeated measurements of that value, we can then calculate a mean and then calculate an error within that mean by using the maximum value minus the minimum value divided by the number of readings taken. But there are situations in physics where you have more than one value, and you've got to take into account the errors that both of those values have and the contribution that they make towards your final answer. And that's when we enter into ideas about absolute and percentage errors. So the experiment here that we're simulating is finding the size of a resistor and expressing its error in both absolute and percentage form. So if we have a look at some of the values that we've got, say we've got a value of voltage of 2.63 volts, and then we've got a value of current of 0.25 amps. If I was to ask you, how to calculate resistance from that, say resistance is our unknown quantity, then I'm sure most of you would be able to figure out that it was V equals IR. It's V equals IR that we would use to calculate resistance. So we can do that. We can go on and calculate that just now. So 2.63 divided by 0.25 gives us 10.6 ohms. So we've got 10.6 ohms, that's our value for resistance that we've calculated. However, we don't know for sure that that is an accurate answer, because there could be errors in that answer. So what we'll go on to look at now is what those errors are. So V, say we read V and we read I from a digital scale. If we've got an analog scale, then we know it's plus or minus half a scale division as our error. That's as accurate as we can be when we're reading off of an analog scale. When we're reading off of a digital scale, then we can have an error of really plus or minus 1 in the least significant digit. So plus or minus 1 in the least significant digit for both of these values will be 0.1. So if we're considering the error in both voltage and current, then it's going to be 0.01. But now we've already got this answer for resistance down here. We've got this 10.6 ohms. We're looking for an error in that 10.6 ohms. How do we get an error from that? Which one of these quantities do we use? Well, the answer to that really is both. Because what we have to do is look at the percentage error that each of those contributes. So to calculate a percentage, just as you would normally, you're looking at the value of the error divided by the value itself to multiplied by 100 to give you what the percentage error is. So each of these errors over here is a certain percentage, so 0.01 is a certain percentage of 2.63, just as 0.01 is a certain percentage of 0.25. That's what we're looking to do, first of all, is to calculate those out using this little equation here. So for voltage, 0.01 is the error, 2.63 is the value, multiplied by 100 we get 0.38. It's not hard to see that current has a smaller value of 0.25, so therefore the 0.01 is going to be a larger percentage than that, so that's 4%. So we've got two values now, two percentage values. We now need to decide which one of those to use. And the answer to that is the biggest one. Whichever percentage is largest, generally the rule is that if you've got a percentage that's say less than a third of the largest percentage error, then you can ignore it. And that's the case here. You've got a 4% error, which is obviously much bigger than a 0.38% error. So we're using this 4% error in our final answer. So it's just really a case of figuring out what 4% of 10.6 is. So the error in R will be plus or minus 4%, so that's you giving it in percentage form. We're also asked for it in absolute form, which is just really taking that percentage and converting it into an actual number. So 10.6 plus or minus 0.424 is roughly 4% of 10.6. But what we always do with uncertainties is try and keep them in the same number of significant figures as our answer here. So it makes more sense to go for 10.6 plus or minus 0.4. So as with our random errors previously, that means that our real value, our value falls somewhere in between 10.2 and 11. So 10.6 plus or minus 0.4. So that's the procedure that we follow if we've maybe not got repeated results, but if we've got a couple of values and we're doing a calculation, then we calculate the percentage error, figure out which one has the largest percentage, and then use that in our final answer to give an uncertainty.